Question 13. We want to evaluate the following integral in the exact and fully simplified form. So we want to integrate 3x cubed plus 5x squared plus 10x all over x squared plus 2x plus 2 with respect to x between -2 and 0. So what we've got here, the first thing we need to notice is that the order of the numerator is greater than the order of the denominator. So the first thing we can do is use long division to get it into a nice fraction where the order of the numerator is equal to or less than the order of the denominator. So to do that, we're going to do long division of x squared plus 2 3x cubed plus 5x squared plus 10x. So 3x cubed plus 6x squared plus 6x negative x squared 10x take away 6x is 4x. And then we can take away 1 negative x squared minus 2x minus 2 6x plus 2. So this function here, this fraction, is equal to 3x minus 1 plus 6x plus 2 all over x squared plus 2x plus 2. And if we say that our integral is called I, then I is equal to the integral from -2 to 0 of this expression. So we've now got this 3x minus 1, which we can integrate, but we've got this quotient left, 6x plus 2 over x squared plus 2x plus 2, that we can't integrate, at least not yet. So the first thing to do, let's take out a factor of 2. So we're going to have our integral 3x minus 1 plus 2 lots of our function here, and I'm going to call this f of x, where f of x equals 3x plus 1 all over x squared plus 2x plus 2. So what we want to do now is we're going to ignore the rest of it, and we're just going to take f of x and we're going to change that into a function which we can integrate. So let's split this plus 1 up on the top. So if we change this to 3x plus 3 minus 2 x squared plus 2x plus 2, so that this way we can split this into two separate fractions and aim to get one of them so that the top is the derivative of the bottom. So the numerator is the derivative of the denominator, and then when we integrate it, that will give us the logarithmic function. So let's split this into two fractions. We can have 3x plus 3 over x squared plus 2x plus 2, and then we're going to take away two lots of 1 over x squared plus 2x plus 2x plus 2. So we could now work our way down, but we've got two separate functions. So I'm going to call this on the right g of x, and I'm just going to leave it as it is for now, so that we can concentrate on what we're doing with this quotient on the left, 3x plus 3 over x squared plus 2x plus 2, and not have to worry what else is going on. So I'm going to multiply the top and the bottom of this fraction by 2, so that then we will have 2x plus 2 over 2 lots of x squared plus 2x plus 2. So because the derivative of x squared is 2x, then up here in the bracket we've got a 2x. So we're getting closer to the function which has the numerator as the derivative of the denominator. So taking this out now, we can further get rid of that 3 over 2, take out completely of this function. So we're left with 2x plus 2 over x squared plus 2x plus 2. And now we have our fraction where the top is the derivative of the bottom, so we know we can integrate that. So now let's have a look at g of x. So g of x is equal to negative 2 lots of 1 over x squared plus 2x plus 2. So this is a simpler quotient. We haven't got a function on the top, but we have got this annoying quadratic on the bottom. So we can't factorize this quadratic, but what we can do is we can complete the square. So completing the square on here will give us x plus 1 squared minus, should be minus, plus 1, okay. And this is taking the form of 1 over y squared plus 1. This is the derivative of arctan of y. So that's d over dy, where y is a function of x. So we now have g of x in a form that we can integrate. So going back, just up the page a bit to there, we can say that our whole integral is equal to the integral from minus 2 to 0 of 3x minus 1 plus 2 lots of f of x, which is 3 2x plus 2 over x squared plus 2x plus 2 plus g of x, which is over here, so negative 4 lots of 1 over x plus 1 squared plus 1. So this 4 comes from the 2 here, and we wanted 2 lots of f of x, and f of x contains g of x, so 2 times 2 is 4, and that is all with respect to x. And now we can simply integrate this, which gives us 3 over 2x squared minus x plus 3 lots of the natural logarithm of x squared plus 2x plus 2 minus 4 arctan of y, and here y is x plus 1. And that is from the limits minus 2 to 0. And substituting those limits in brings us to the value of the integral to be minus 8 minus 2 pi. So what we did was we started off using long division to find a expression which had a fraction with the numerator smaller than the denominator. Then, because we had this fraction on the right hand side, we had to split this up into 2 fractions so that we could integrate it. And that came out to minus 8 minus 2 pi. I hope you found this useful. Thank you for watching.